Okay, this is the P4 paper from October 2021. It's question number 9, and as you can see by looking at this, this is a differentiation question, and in particular a rates of change question. So let's just have a look through it. We've got the diagram up here, and then most of the information down here relates to the actual size of the diagram. So we know the height of the cylinder is 4.2, the radius is 8. We know that for the water, the height is equal to h. And it says we've got water flowing into the tank at a constant rate of 0.6 pi meters cubed per minute. So in my mind, don't necessarily write that down, but I think that's a dV by dt. How come? Well, that's volume and that's time there. So the units can quite often help us. So I've got dV by dt of 0.6 pi. But there's a tap at the bottom and water's coming out, at a rate of 0.15 pi h meters cubed per minute. So when I'm going to do my dV by dt, which I will do, it's actually going to work out to be this minus this. But that's when we get properly into the question. What does it say? It says show that dH by dt is equal to something. So if I've got dV dt and I've got dH dt, I would imagine that the thing that I've got left is going to involve dVs and dHs, and given that I know the volume of a cylinder is pi r squared h, I'm probably going to be starting with volume equals pi r squared h. Now, I want to get dV by dH, so I need to not have r in there. There are lots of different ways on these questions that they get rid of r, but in this particular case, it's simply the fact that r is equal to 4 because the diameter is equal to 8 there. Okay, having said all of that then, let's actually make a start with the question. So what we can begin by saying is pretty much the last thing that I just said there, which is I know volume of a cylinder is equal to pi r squared h, but in this case r is equal to 4, so I'm going to get V is equal to pi 4 squared h. I'm going to get V is equal to 16 pi h, and so that means I can get one of my dVs, one of my dV by dH in this case, differentiate that, gives me dV by dH is equal to 16 pi. Now we've already talked about dV by dt, and try and work out dV by dt. We've got water going in at a rate of 0.6 pi, and we've got it coming out at the bottom at a rate of 0.15 pi h. So brilliant, I've got dV by dH, I've got dV by dt, and the question said, can we show dH by dt up there? So if I want to do that, dH by dt then is going to be dH by dV times dV by dt. Just check there, the dVs would cancel and I get dH by dt. So in what I've got here, compared to my dV by dH there, all I need to do is to invert it, is to turn it upside down. So dH by dt is going to be 1 over 16 pi times dV by dt, and dV by dt is 0.6 pi minus 0.15 pi h. Well, first of all, we could take the pi's out if we want. That pi can cancel with those two, so we'll get a 16th of 0.6 minus 0.15 h. So the pi's can cancel there. And then what are we trying to get it to? So we're trying to get it to look like 12 minus 3h over 320. Don't go too quickly with that, okay? So if we were looking at that, what I could do is say, what do I want to get to? Well, I could say that, let's go back and have another look, sorry. We've got 320 on the bottom there. So if I at this stage then said, let's multiply top and bottom by 10, I'm going to get 1 over 160 is equal to 6 minus 1.5 h And then I think it's a fair enough step to say double everything up again, 1 over 320, and then we're going to get 12 minus 2h. Sorry, 12 minus 3h. Be able to multiply properly. 12 minus 3h, and that's actually the answer. So, yeah, I think that's enough steps to be able to do that. So, dH by dt, as asked for in the question, is 12 minus 3h over 320. Right, what do we do next? So next it says, given that the depth is 0.5 when the tap is opened, so that means that h is equal to 0.5 when t is equal to 0, so they're giving me some information. Find the time taken for the depth of water in the tank to reach 3.5. Okay, so I know exactly what I'm going to be doing here then. Anybody that's done any work on this stuff should have really no issues with the fact that I've got dH by dt is equal to 1 over 320, 12 minus 3h. What I'm going to do is try and solve this differential equation. I'm going to integrate both sides. I'm going to separate the variables. And the fact that they gave me all that information means I'll know limits to put in, and I should be able to work out what's missing. So here, if I'm looking at this one, I can see that I've got dH, and I'm going to need to take the 12 minus 3h over to the other side there, is going to be equal to dt, and then the 320 here. Now, it's absolutely up to you, so I'm going to integrate both sides, integrate. If you wanted to put that 320 up there, it would have had no difference to the question whatsoever. I'm quite happy to have this like this, and then be thinking, what have I got on this side? There's where I've got a little bit of a complication. And if I've got basically 1 over x, we know the the integral of 1 over x is log x, isn't it? So I'm going to get that the integral of 1 over 12 minus 3h is log 12 minus 3h, but I've now got to take account of the fact that I've got a minus 3 in there. I'm not going to spend any time on this. We're at the very end of a P4 exam. By this stage, if you're not sure how to do that, go back and do some other revision before you come back and have a look at this question. So the integral of the left-hand side is equal to that. The integral of the right-hand side is just t, t over 320. And then obviously we have to have a constant of integration. So plus c here. Now I'm going to pay a little bit more attention to what they told me. They told me that at t equals 0, h was equal to 0.5. So if I put that all in, t is equal to 0, h is equal to 0.05, I'll get c on this side, and I'm going to get minus a third log. If h is equal to 0.5, that's 3 over 2, that's 12 take away 3 over 2, and 12 take away 3 over 2. If I'm leaving it as a fraction, which I'm going to for the time being, gives me that as being my constant of integration. So what that then means is that it's minus a third log 12 minus 3h is equal to t over 320 minus a third log 21 over 2. I'm just looking at that one up there and putting in now that we have the constant. And then if we go back and look at the question said that h is going to be equal to 3.5. Can we work out what t is going to be? So if I'm trying to work out what t is going to be in here, if I put h equal to 3.5 in, let's just take everything over to one side. I'm going to get that t over 320 is going to be equal to, it's this thing that I'm going to just take over to the other side. I'm going to get a third log 21 over 2 minus a third log, and as I say, if I put h equal to 3.5 there, that just works out to be 3 over 2 here, and then it's just tidying this up now. Do we need an exact answer? What do we need here? Well, if I took the third out, it's a third, and then I've got log a minus log b, so you can just divide those two. It's log of 21 over 2 divided by 3 over 2, so that's actually a third log 7. That's quite neat there, which means then that t is equal to 320 times that. So 320 over 3 log 7. Let's just go back and see what they want us to do with it. They want the time taken. They don't want what time is it. It's not 1:30 p.m. in the afternoon or whatever. It's the time from our question. The time is in minutes here. So if I have multiply that out, it comes to 207.56. Excuse me, 207.56. I'm going to call that 208 minutes then. Okay. Just go back and make absolutely certain here that we've answered the question properly, that there's no complicated parts to that. There aren't, but just be careful as we're going through and doing that. Right, long question there, but hopefully that all makes sense.